Welcome to the lab, the demo on the synthesis of hexanol. Now I said hexanol, I did not specify what hexanol. We began with hexene, one hexene, which has a double bond between carbon 1 and carbon 2. And we can get the OH group either on carbon 1 to produce one hexanol or on carbon 2 to produce 2 hexanol. One hexanol has a boiling point that's different from 2 hexanol, and between the two products, 1 hexanol and 2 hexanol, one will be major and the other will not be major. According to Markov-Nikov's rule, what should be the correct major product? If you said 2 hexanol, that's right. So the major product which we are going to synthesize is going to be 2 hexanol, not 1 hexanol. Now, how exactly are we going to carry out this synthesis? What we will do is we will first have to prepare 85% sulfuric acid from 98% highly concentrated sulfuric acid. We will add about 4 to 5 grams of mixture of icy water to exactly 15 ml of 98% sulfuric acid in a 125 ml flask. Once we do that, it's going to be 85%. It's very important for this experiment that the sulfuric acid be cold as well as have the concentration that's 85%. If it's less than that, the reaction will not proceed as we plan. Then we will transfer that acid to 125 ml separatory funnel, and then to that we'll add 10 ml of hexene, one hexene, and shake it vigorously for 5 minutes. Originally the two layers, hexene layer will be separate from the sulfuric acid layer. Sulfuric acid is very highly polar, while hexene is an organic compound. We'll have two layers, but as we shake, the reaction to produce 1 hexanol and 2 hexanol through addition reaction will start taking place. And it happens at the boundary between the two layers, but as we shake it vigorously, we sort of create more boundary at different points. More molecules are of each of the kind. Sulfuric acid and hexene are introduced to each other at a new boundary, and so the reaction continues. And as the reaction happens and it's at the end, and we look at the separatory funnel, we will see that it only has one layer. That's when we know that the reaction was successful. At that point, we will add 10 more milliliters of hexene and continue our shaking vigorously of the separatory funnel. And obviously, we will have to burp it every few seconds in order to release any volatile gases. But it's very important to realize that if you do not have a homogeneous single layer after the addition of total 20 ml of hexene, that means that the reaction did not take place the way it should. And the most likely reason is because the acid was not concentrated enough, or it was not cold enough. Obviously, the reason why we want it to be cold is because this reaction can release a lot of heat, and so we want to make sure that it's cold and it has an 85% concentration. Any higher concentration can also result in side reactions which we do not want to see happen. So once the reaction is complete, we have our mixture of hexanol, 1 and 2 hexanol, as well as sulfuric acid. I expect you to give me the reaction mechanism for this reaction, including the formation of the minor product, 1 hexanol, and major product, 2 hexanol, in your lab notebook. And once the reaction is complete, we should have a mixture, like I said, of many components, but it will be one homogeneous layer. We will do a distillation. When we do distillation, this is once again a steam distillation. What we will be collecting will be a mixture of water and our hexanols, both of them, organic as well as water. Sulfuric acid that's unreacted will not distill over because it has a very high boiling point. We won't be distilling it all the way over there. And at the same time, I want you to be able to tell me which is going to be the limiting reactant in this reaction as well. Is it sulfuric acid that's the limiting reactant, or is it hexene? you need to know what is the limiting reactant in order to find out what the percent yield should be of the major and minor products, and what's the theoretical yield. Based on the actual yield, you can find out the percent yield. Now, after we do the steam distillation, we know from previous experiment with SN2 synthesis how in the distillation we collected water and we collected bromobutane. We know how we learn when to stop with our distillation, when we stop collecting any more water insoluble organic compound. So we will periodically check during our steam distillation. If we don't collect any more water insoluble organic compound, that's when we will stop. And so we will have in our collection flask a mixture that we will then put it back in the separatory funnel, where we will have two layers. We will discard the aqueous layer and we will keep the organic layer. We may have to salt out our aqueous layer to remove any emulsion in it. And once we get our organic layer, then we will dry it of any water using a drying agent, and finally do our second distillation, this time collecting our product at 136 degrees. 136 degree is the boiling point of our 2-hexanol. Anything we collect before that is going to be the forerun. It could be other minor side products which we do not want to collect, which was not the aim of this experiment. This is an addition reaction, an electrophilic addition reaction on the double bond. Okay, so with that said, let's get started.